At 13:47 hours in occupied Zaporizhzhia, 12 Ukrainian drones pushed through the low morning haze, flying toward a Russian ammunition train at just under 100 kilometers per hour. In a concrete bunker several kilometers away, their operators watch grainy video feeds instead of the sky. What they do not see is that Russian artillery has already begun to bracket their position. The first 152mm shell lands roughly 800 meters away, close enough to sprinkle dust from the ceiling and rattle loose stones from the tunnel walls. The Russians picked them up the instant. 48 brushless motors spun up at the same time. That burst of electromagnetic noise rose from the tree line like a flare on every spectrum analyzer within 10 kilometers. To an artillery battery watching the electronic environment, it looked like someone had turned on stadium lights in the middle of a blackout. Inside the bunker, the Ukrainians understand what that means. They can cut power and live, abandoning the mission, or keep the drones in the air while shells walk closer. To reach the train, they need around 12 minutes. To pinpoint the launch site, the Russian guns need perhaps 3. They keep the drones moving. Far ahead, a Russian armored personnel carrier rolls along a dirt road parallel to the tracks. A gunner standing half exposed behind the turret hatch notices a dark cluster against the sky. 12 dots, low and fast. He swings his machine gun up and opens fire. Tracer rounds climbing in bright arcs. The swarm fractures on command. 4 drones climb. 4 drop to treetop height. 4 continue straight through the middle. Rounds crack through the air where they had been a heartbeat early, but there is something the Russians cannot see from below. Trailing behind each of the drones is a line of glass thinner than a strand of human hair, a fiber-optic tether spooling silently from a reel. While Russian electronic warfare vehicles flood the air with noise across every common frequency, those filaments carry control signals as rapid pulses of light. Jamming works on radio waves. The fiber simply ignores it. The very expensive electronic warfare truck, parked near a junction, bristling with antennas and emitters, is reduced to the usefulness of an oversized diesel generator while the drones hum overhead, untouched by the storm of interference. The Russian artillery, however, is a different problem. The second shell lands 600 meters away, the blast rolling through the bunker like a muted thunderclap. The Ukrainians are not surprised. They planned for this. Their control teams are divided across 3 bunkers spaced roughly 500 meters apart, connected by narrow communication tunnels. That number was not random. A 152mm shell can produce a lethal fragment radius of around 300 meters. At 500 meters of separation, a direct hit on one bunker might shred it completely, yet leave the others untouched and fully functional. The Russians could be fortunate and smash one shelter. With extraordinary luck, they might catch 2, but they can never destroy all 3 at once with map fire. At least 8 drones will remain under competent control, no matter how accurate the barrage becomes. That guarantee is the backbone of the plan. The third shell lands closer still, roughly 450 meters away, and this one does more than shake dust from the walls. Shrapnel scythes through the air above the bunkers and across the valley, tiny shards moving at several times the speed of sound, indifferent to distance or intention. 3 fragments find their targets, slicing through 3 of the near-invisible tether. The glass filaments are only a few millimeters thick and part instantly. Drones 2, 5, and 8 lose their lifelines. Each of the severed aircraft shifts automatically to backup radio control and internal battery power. Logic boards following contingency programming without hesitation. It keeps them flying, but it also exposes them to the full weight of Russian jamming. The other 9 drones, still linked through their fibers, continue to receive guidance as pulses of light racing through curled glass at a significant fraction of light speed. In Bunker 1, the senior operator issues the order they rehearsed. Maintain control of all surviving drones while shifting station. Equipment is unplugged in a practice sequence, consoles folded, cables coiled. As the team withdraws into a low connecting tunnel, the next artillery shell slams into the empty bunker behind them. A direct hit that would have shredded human bodies. Chunks of reinforced concrete bounce off steel ribbing above the passage, while the team runs toward their alternate position, several hundred meters away. When they plug back in, their drones are still flying, still closing the distance to the train. The difference between radio and fiber is now painfully clear to the Russians as well. Inside the electronic warfare vehicle, an operator watches his wideband display as the system lights up. The incoming drones are detected at around 7 kilometers. He instructs the system to transmit across a broad band from around 100 megahertz through several gigahertz. Kilowatts of power pour into the sky in a controlled roar, designed to drown out everything from civilian drone link frequencies to satellite navigation signals. On his screen, 3 of the tracks wobble, then vanish into noise as their control links die. 9 others remain, disturbingly crisp. Their signal paths are not in the air at all. They travel through glass that runs all the way back to Ukrainian bunkers buried under meters of earth. The operator checks his equipment, then pushes more power into the air, saturating even more spectrum. He is trying to shout down a flashlight beam by yelling louder. The physics are indifferent to his effort. The 3 drones on radio backup are gone, their pilots staring at frozen frames and static. They will fly straight until batteries die, or they meet a tree, harmless now. The side effect of all that jamming begins to surface. The armored vehicle, at a checkpoint near the line, can see the swarm on thermal imaging and attempts to warn a nearby air defense unit. The crew hears only static, their encrypted radios live in the same spectrum, being hammered into uselessness by their own specialists. Russian forces have pulled a thick electromagnetic curtain across the battlefield and cut off their own vision beyond it. The 9 tethered drones do not care. They slide under that curtain like fish beneath a frozen river, following waypoints set by hands that never left the shelter. Out along the rails, the train engineer has been briefed about the rising threat from drones. His response is simple. He pushes the throttle levers forward until they meet their stops. The heavy consist groans as thousands of tons of steel, fuel, ammunition, and classified cargo begin to accelerate along worn track. Speed creeps upward from the low 40s to the high 40s and beyond. Inching toward the maximum the aging rails can safely handle. Each increase seems small from the cabin, but it has a brutal effect on the men guiding the drones. Every extra kilometer per hour, the train gains moves the planned intercept point several meters farther down the line. The operators must continuously adjust their courses, burning precious battery reserves as they fight both headwinds and moving coordinates. Back near the checkpoint, the crew of the armored carrier gets their own short window. The swarm is crossing their field of fire at an oblique angle, just inside the envelope, where their main gun can reach. The gunner tries to solve a geometry problem in his head. Small targets, fast lateral speed, very little time. He knows he must fire not at where the drones are, but where they will be after bullet flight time. At their current speed, that means leading them by several body lengths, pushing rounds into empty air and waiting for the drones to intersect the stream. In theory, it is routine. On a range, targets move predictably along rails. In reality, every drone jerks up, down, left, and right in random evasive movements every second or two. Their fiber-optic tails flash and vanish like spider silk in sunlight. He is chasing phantoms that change direction faster than he can adjust. He walks his bursts across open sky, but by the time his tracers touch a path, a drone once occupied, the machine has already slid somewhere else. 8 seconds after he starts firing, the swarm disappears behind a line of trees, leaving nothing but empty branches and drifting smoke. His commander slams a fist against the hatch rim, frustrated and powerless to report the failure, his radio still choked with friendly jamming. The drones, untouched, continue to close, now only a few kilometers from the part of the track the Ukrainians have named simply the window. That window is a stretch of line where the rails run straight through open country for several kilometers, away from heavy defenses, away from urban cover, and away from overhead protection. The Ukrainians watch this section for weeks through satellites and scouts, measuring timing and speed. They know how long a train will remain exposed here. They know which side roads lead to it. They know that in this brief corridor, the train is naked. The artillery rounds continue to fall behind them, but those echoes are growing less frequent, the guns shifting fire, unsure if the target is still there. At the edge of that corridor sits the Russian air defense system, tasked with making sure no threat reaches the rails. Its search radar struggles to distinguish the tiny drones from ground clutter and heat shimmer, so the crew switches to optical tracking. On their screen, the swarm appears as a loose cluster of flickering specks. The operator selects gun mode. Under the turret, twin 30mm autocannons spool up, each shell pre-programmed to detonate, not on impact, but at a specific distance, turning single rounds into expanding clouds of steel fragments. The gunner knows he cannot afford to aim at individual drones. They are too small, too agile, and too numerous. Instead, he paints the sky with calculated volumes of shrapnel. At a few thousand meters, the first string of shells erupts in mid-air, each one bursting into hundreds of razor fragments. One of the drones simply disappears in a white flash, its video feed cutting to static. A second is torn apart seconds later, its last frame showing streaks of metal rushing toward the lens. The remaining drones react as if they were stung. On the Ukrainian side, the operator responsible for overall coordination orders an immediate split in 3 dimensions. 3 drones climb sharply, presenting darker silhouettes against the sky. 3 drop so low that their propellers almost comb the tops of the grain stalks. 1 holds an intermediate altitude, sliding sideways in erratic movements, a decoy in open space. The air defense computer flags the higher group as easier to track. Training doctrine insists that the closest threat should always take priority. The gunner has only a heartbeat to choose between instinct and algorithm. He raises the barrels toward the climbing drones, committing to the path his computer recommends. In that moment, the low group races forward almost untouched, hugging the folds of the terrain and taking advantage of every blind angle. By the time the gunner senses the mistake and tries to swing his guns down, the low drones are already beneath his optimal engagement arc, slicing into a region of space his weapons cannot cover. Without redesigning the turret ring, the system has been built to fight cruise missiles and fast jets, not slow insects crawling along the ground. Along the line ahead, a small Russian observation post sees the drones coming and adds its own fire. Dozens of rifles and light machine guns snap from their rests as soldiers aim at the sound of buzzing engines. The geometry is unforgiving. The drones are crossing perpendicular to their firing line, moving at the speed of a car on a highway, but much closer and much smaller. Human reaction time eats a quarter of a second before a trigger finger even tightens. Aiming adjustments take another fraction. By the time a sight picture settles on a target, it has already moved on. Tracer rounds stitch the air behind the drones, painting straight lines where curved solutions were needed. Some soldiers fire rocket-propelled grenades upward, hoping to detonate near the swarm, but the fuses and trajectories were never meant for small aerial targets. The explosives burst in impressive fireballs with no practical effect. While that chaotic curtain of fire burns itself out, 4 of the Ukrainian drones that have been loitering at higher altitude peel away from the main axis, banking in a tight arc toward a segment of track far behind the moving train. Those 4 machines are not aiming for the train at all. They dive toward the rails themselves, targeting a section several hundred meters behind the last wagon. On approach, each drone releases a small, dense canister. On impact, the canisters crack open and pour out a stream of material that does not explode so much as ignite in an almost blinding white glare. It is a mixture of metal powders and oxidizer designed to reach temperatures that ordinary explosives cannot match. Where it touches steel, the rails do not bend or crack. They begin to burn. Railroad steel softens and fails at temperatures lower than that sustained by the burning mixture. Within moments, neat parallel lines of heavy metal are transformed into molten gaps, sagging and collapsing under their own weight. To a train approaching at speed, the rails will appear intact until the very last seconds. Structurally, though, they are already gone. The drones that delivered the charges have already expended their payload and value. Their sacrifice was planned into the mission profile from the beginning, one set of tools to prepare the ambush for another. Back at the air defense system, those twin cannons have been firing at near maximum rate. Modern autocannons can maintain extreme output for a short burst. If firing continues beyond a safe threshold, the rifling inside the barrels warps. Rounds begin to tumble instead of spin, spraying unpredictably and chewing up the guns from the inside. The gunner has to make a choice between continuing ineffective fire or pausing. He releases the trigger. For a dozen seconds, the sky near the train is free of large caliber fire. The surviving drones push forward, batteries draining faster than planned as they fight both distance and wind. On their control screens, icons begin to flash amber as charge levels fall into critical ranges. One drone shows less than 1/5 capacity. Another drops toward that threshold. The operators know exactly how many seconds of flight remain at their current power draw. They also know it is barely enough to cover the distance if nothing else goes wrong. Smoke from the burning rails and ignited grass is now drifting across the battlefield, pushed by a light crosswind. That smoke carries carbon particles that absorb infrared energy across a wide range of wavelengths. Thermal cameras that could easily see through darkness and rain now stare into an opaque gray wall. Russian positions lose their only reliable way to track the drones. For a brief window, the aircraft are not just small and agile. They are effectively invisible to anything that is not close enough to hear their electric motors whining in the air. As the drones emerge from the far side of the smoke, they are less than 2 kilometers from the train. Every bolt, rivet, and identification number on the wagons is visible on their feeds. The fiber-optic lines trailing behind them are nearing their own limit. Each reel holds a fixed length of glass filament. Beyond that, tension rises and tangles become a threat. To prevent a tether from snapping at the worst moment or dragging on obstacles, each line is rigged to release automatically once it reaches a predetermined extension. Meters tick down on a small indicator in the operator's field of view. When the line plays out, a simple mechanical latch opens and the fiber falls away, whipping back toward the earth. One drone drops its tether a few meters earlier than expected as the spring lets go. Instantaneously, its control link shifts from fiber to radio, and its battery display drops into single digits. The others follow over the next few seconds. All remaining drones are now exposed to jamming, but they are also close enough that inertia, if properly used, can carry them to the target. In the locomotive at the front of the train, the engineer finally sees the incoming threat clearly, a cluster of dark shapes rising and falling over the tracks ahead. He pushes the throttles beyond their designed limit, overpowering mechanical stops. Diesel engines roar as injectors flood cylinders with fuel. For a few heartbeats, the speedometer nudges higher. Then physics takes its own revenge. Steel wheels on steel rails can grip very well under controlled load, but once they begin to slip, the friction curve collapses. The driver is now polishing the track instead of pushing against it. Hidden under the forward part of the train, the air defense system attempts one last engagement. The drones have crossed into its minimum effective range. The guns cannot depress far enough to fire on targets that low and that close without hitting their own protective berm. The system has been optimized to shoot at threats coming from above, not level with the track. The operator can only watch his screen as the drone tracks drop below his engagement arcs, sliding into a blind spot defined not by enemy cunning, but by simple angles and engineering constraints. Russian troops near the final checkpoint throw everything they have into the air. Machine guns vibrate on bipods, rifles snap, and more rocket-propelled grenades arc upward. The drones stay centered over the railway, directly above the line of wagons. Soldiers would need to fire through their own train, punching holes in the very cargo they are there to protect. Few are willing to take that risk. Most rounds pass wide or high. Some ricochet off metal sides. One drone takes a glancing hit that cracks its battery casing and tumbles into a field, spent. Another drone suffers a different kind of failure. Its battery monitor hits zero, while it is still a short distance from the target. The electric motor cuts out abruptly, propellers turning into windmill. Yet momentum has no need for power. The drone continues forward on its existing velocity, losing height only slowly over the last stretch. In the control bunker, the operator watches the final video feed as the image jitters and drifts. Guided now only by the balance between drag and inertia, no longer an aircraft, but not yet wreckage. Behind the drifting dust and shuddering steel, the final wave arrives. One drone slams into the coupling between the locomotive and the first wagon, its shaped charge punching a narrow jet of molten metal straight through hardened steel. A heartbeat later, more impacts ripple across the train. Fuel lines rupture into vapor. Brake systems seize. An ammunition wagon, its internal seals weakened by days of vibration, takes a direct hit that forces its temperature past the point of ignition. The resulting blast is not an explosion so much as an eruption, a pressure front racing outward faster than sound. Entire wagons vanish into incandescent fragments. Others lift from the tracks and tumble across open fields in twisting arcs. In seconds, what had been thousands of tons of cargo becomes a cratered scar along the rails and a rising plume of smoke. A handful of lightweight drones, costing barely more than a family appliance, have erased a vital artery, feeding multiple Russian formations, and ended the voyage of a train meant to hide its purpose behind routine movement. The rails collapse into molten gaps, the sky fills with drifting embers, and the battlefield settles into a stunned silence broken only by the crackle of burning metal. The mission, built on precision, endurance, and relentless adaptation under fire, closes with the simple truth that reach and mass matter less than timing, ingenuity, and the patience to wait for the exact moment the enemy loads the wrong cargo onto the wrong train.